Okay, in this video we'll be simplifying radicals, specifically simplifying square roots. So if we take the square root of 27, put that in our calculator, we get a decimal value. We want exact values. So the goal is to rewrite 27 with a factor that has a perfect square root. When I say perfect square roots, we can put in x squared in our calculator and get all of those. So 4 has a perfect square root, 9, 16, 25, 36, 49, etc. They all have perfect square roots. So 9 has a perfect square root of 3. So I'm going to rewrite the square root of 27 as the square root of 9 times 3. This is equivalent to this, so that's okay to do. Now, the square root of 9 is 3, so I'm going to move that in the front, and we leave the 3 behind. So the square root of 9 is 3, it comes out, and the 3 stays behind. So 3 square root of 3 is the same as the square root of 27. I can prove that to you. If we put that in our calculator, 3 second square root of 3 is the same exact decimal value. So this is exact. Now we have simplified this radical. Square root of 27 is not considered simplified. This form right here, 3 square root of 3, is considered simplified. Okay, second example here, the square root of 12. So we want to rewrite 12 with a factor that has a perfect square root. That would be 4 and 3, 4 times 3. 4 has a perfect square root of 2. So in the next step, the square root of 4 is 2, and then the 3 is left behind. So the square root of 4 moves in the front as a 2. The 3 stays behind. So we can verify that. Square root of 12 is this decimal, and we should see that 2 square root of 3 is the same, and it is, so this is correct. This is not simplified, this is. You know it's simplified when the remaining part underneath the radical will not simplify anymore. It doesn't have any factors that have perfect square roots. So 2 square root of 3 is the simplified form of square root of 12. Example 4 here, 5 square root of 16. 16 is one of those numbers with a perfect square root. Its square root is 4. So we have this 5 square root of 16 to begin with. Well, the square root of 16 is 4, so it moves in the front. We already have a 5 there, so that has to be multiplied. Notice we're multiplying 5 times the square root of 16. The square root of 16 is 4, so when that 4 is moving in front, we have to end up multiplying those, so we end up with 20. The final answer there is 20. So for clarification of what's happening, we are starting with this, 5 times the square root of 16. 5 times the square root of 16. The square root of 16 is 4, so we have this, 5 times 4. This is equivalent to this, so our final answer is 5 times 4 is 20. That's what's happening there. Okay, one additional example, 3 square root of 18. So our goal is to simplify this square root of 18. 18 has factors of 9 and 2, where 9 has a perfect square root. I wouldn't use 6 and 3 because neither 6 or 3 has a perfect square root. I want to use 9 and 2. 9 has a perfect square root of 3, so I'm going to bring it up front. I have to end up multiplying these two together. 3 times 3 is 9. The 2 was left behind, so 9 square root of 2 is equivalent to 3 square root of 18. Alright, so number 15, negative 6 square root of 512. 512 is a big number, so we can use our calculator here. That's fine to do. I'm going to find factors of 512, and as we've done all year, if you want factors of those bigger numbers, you just put that number over x and go on your table and look at all of them. So we have 2 and 256. So we're looking for a number that has a perfect square root. So I see 4 and 128. Those 128 is pretty big, so I'm going to keep looking for others. 8 and 64. 64 has a perfect square root, but that's still a pretty large number, so I'm going to keep looking here in my table. So the next perfect factor is 16 and 32. That's the one I want to use, 16 and 32. 16 has a perfect square root, and then I can break that down from there. So negative 6 square root of, instead of 512, I'm writing 16 times 32. Alright, so square root of 16 is 4, so I'm going to bring that out. So I'm going to replace that, bring it out as a 4. The square root of 16 is 4. Now I multiply the 4 that's coming out there by whatever's in front, negative 6. So that would be negative 24 square root of 32. Okay, now I look at square root of 32 and I ask myself, is that simplified? So let's say you didn't find the largest number, which we didn't in this case on purpose. So this 32, does it have any factors that break down that have perfect square roots? And it does. So negative 24 square root of 32 is the same thing as 16 times 2. 32 is equivalent to 16 times 2. Now, the 16 has a perfect square root of 4, so that's moving in the front. So I have negative 24 times 4, so that would be negative 96, and the 2 is left behind. So here is my final answer, negative 96 square root of 2. I know that I'm done. It's fully simplified because the part left underneath the radical doesn't have any factors that have perfect square roots. So negative 96 square root of 2, final answer.